All right, hello everybody. This is Mr. Bear, and I'm going to show you how to do this free response question using Desmos. All right, so let's first figure out what's going on here. So it says the table gives the number of people that are exercising in a large gym. At 7 a.m., which is time t equals 0, there were 84 people exercising in the gym. 5 hours later, at t equals 5, there were 21 people exercising inside the gym. At 6 p.m., t equals 11, there were 68 people that were exercising in the gym. The number of people exercising in the gym can be modeled by a quadratic function w, which is given by w of t equals a times t squared plus b times t plus c, where w of t is the number of people exercising inside the gym t hours after 7 a.m. All right, so a couple of things to note right away is the number of people. They're calling this, whoops, let me put this not in highlighter mode. They're calling the number of people w of t. All right, and so when I build my equation, I need to realize that my w of t is going to be the output variable. So the 84, the 21, and the 68 are going to be the output quantities. When we write our three equations that can be used to find the constants a, b, and c in this equation, we're going to start with our w of t values. So I'm going to start with this 84. So we're going to have 84, whoops. So sorry, I hate when my tablet does this, okay? So as I was saying, we're going to start with that 84. 84 is equal to, now remember, a, b, and c are the constants that we don't know, but we do know the t value that goes with it. So I'm going to write a times 0 squared plus b times 0 plus c. Now that is enough to write an equation for that first one, but some of you may say, hey, wait a minute, the a term and the b term will ultimately just be 0, so could I just say that 84 equals c? And if you asked yourself that, you would be correct. All right, so we can write it like that. You could have also left it as I originally had it. All right, now we're going to do the next input. So for when our output is 21, and our input for that is 5. So it'll go a times 5 squared plus b times 5 plus c. Now, some of you may say, Mr. Bear, I can write this as 21 equals 25a plus 5b. And guess what? I know that c is 84, so I might write it like so. That's fine. You do you, boo. All right. Third one, output is 68. And the input for that is 11. So we'll have a times 11 squared plus b times 11 plus c. And again, if you wanted, you could rewrite this as 68 equals 121a plus 11b plus, you guessed it, that c is 84. All right, so you could write it any of those ways. All right, but part 2 rather, is going to say find the values for a, b, and c as decimal approximations. My recommendation is to store the full equation in Desmos, though. That's not a recommendation. Let's make that a requirement, okay? All right, so what we do is we run the regression for this function, and for this, we are going to need Desmos. So let me go ahead and pull that up. Remember, you want to search the College Board Desmos. If you have Mr. Bear, you will be able to just click the link posted on Google Classroom. I am not sure if Miss Majors has done that for her kids. And if she hasn't, maybe you can convince her to do so now. All right, so we're going to go ahead and add our table. For whatever reason, this is a different language. That's a little weird. Here we go. There we go. Let's see if this is, there we go. English. That's what I need. All right, so we're going to hit that little plus sign up at the top, and we're going to go to table, and we're going to input our x values first, which are actually our t values according to the model. My t values were 0, 5, and 11. And my y values, which were our W of t, we had 84, we had 21, and we have 68. Okay, so we have our function values there, and just so that we get an idea here, this is the scatter plot. But we are interested in finding the values of A, B, and C. So I'm going to hit this little icon up here. I don't know if you could tell what I did there. Let me delete that and show you again. So that little icon that looks like dots with the line through it, you click that, and it gives you this drop down. We were told to run a quadratic model, so I click quadratic regression. And when I do that, I can see my equation right here. All right, so my equation, I use those numbers here. I'm going to go ahead and click this little icon next to the word equation and get that equation into my calculator. I'm going to also go ahead and pause to write down what this is. So let me go ahead and do that real fast. Okay. So going back to our document, oops. Oh, goodness. Sorry, I'm trying to get used to doing this on here. Okay. So, according to my Desmos, I had an A value that was equal to 1.85758. You only need the first 3 digits. You do not have to round that third digit. I encourage you to write out as much as you can. Our B value is negative 21.88788. Again, you only need the first 3 digits, but the more you go out, the better you will be. Our C, since it was exactly equal to 84, we do not have to put any decimal points after that. Only if you get an exact whole number or an exact truncated decimal do you not have to worry about the 3 decimal places. All right, so you could write them out like so, or you could have written the equation let's use W of t equals 1.857 t squared minus 21.887 t plus 84. Either way is fine. That you either can identify the A, B, and the C separately, or you can write it as an equation with the A, B, and C plugged in. Okay? All right, so that is how you're going to handle that part. So then the next part says, what is the predicted number of people at 2 p.m., meaning t is 7. So let me show you how to do that using your Desmos. Okay, close that out. All right, so if we go back to where we had our equation, when we hit that little button here that got the equation put in here, it gives it to you as y equals. What I'm going to do is I'm going to change my y equals. I'm going to rewrite that as W of t so I can keep consistent with the problem. But in order to do that, I need to change my x's to t's, all right? You don't have to do this. You could just have called this f of x and just been done with it. But I want to make sure that I am doing things the way that the problem says. And so I changed my x's to t's. And now what I've done is I have defined my function as w of t equals this equation. So it kind of matches more with what they provided. Okay, so now I've already forgotten what I was asked to find. I need to find the value of 2 p.m., which is t equals 7. Since I've defined what my W of t is, all I have to do now is just go here and type W of 7. And it gives me 21.80626. So I'm going to go to my paper. Not there. And I'm going to write W of 7 equals 21.80626. Now, I know you might be thinking, Mr. Bear, though, it says what's the predicted number of people. we wouldn't have 0.806 of a person. You're right, but remember, this is just a model and it's an approximation. And it also asks us to give our answer as a decimal approximation. So we are going to give the decimal approximation. And if you give this value and then say W of 7 is about 22 people, as long as we see this, you're okay. You can say it's about 22 people as long as you show this decimal approximation. If you just jump right to saying W of 7 is about 22 people and you did not put the decimal approximation, you will not earn that point. I know it sounds harsh, but that is how the AP exam does it. Okay, so now we're going to look at the next part. It says, use the given data to find the average rate of change in the number of people exercising inside the gym in people per hour from t equals 5 to t equals 11 hours. Express your answer as a decimal approximation. Show the computations that lead to your answer. All right, so if you remember, average rate of change formula goes f of b minus f of a over b minus a. All right, so in our problem, the t equals 5 is our a, and the t equals 11 is our b. So what I would do is I would figure out w of 11. I'm using w because my function name was w, minus w of 5 over 11 minus 5. And before you think, oh my gosh, now I got to go and plug that in, work that out. No, you don't. We're going to take that equation exactly as I wrote it here, and we're going to go right to our Desmos. And what we're going to do now is we're going to create an equation. I'm going to go ahead and get my fraction. We're going to have W of 11 minus W of 5 over 11 minus 5. And look, 7.8334. That is your average rate of change on that interval. Simple as that. I keep forgetting about this. So sorry. Let's erase the stray mark. And now let's scroll down. Okay, so I'm already forgetting what my answer was. So let me go to my key that I already made. It was 7.8334. To earn this point, you must show the computation and show the decimal approximation. If you only show one of those and not the other, you do not get the point. Okay, it sounds harsh, but again, that's how they grade on the AP exam. So show the computation. This is literally all you need to show. And then show your decimal approximation. Okay? All right, the last two parts here. Well, the last part, the two sections of it. Now we're kind of done with that scenario that we had up above. So put all that out of your mind now. And now we have this function g of x is equal to this rational function. All right, so what we're going to do is we will go back to our Desmos. We're going to clear everything else out, and we're going to type in this new function g of x equals this function. It's going to ask us to find the values of x for which g of x equals 5. Let's see how easy this is to do. So I'm going to take this g of x function, I'm going to go back to my Desmos, and I'm going to type this in. So first, let me just clear out everything I had there. And I'm going to call this g of x equals, then I'm going to go to my key I have here so I can see how to type it in. It'll be x squared plus 5x minus 9. And then on the bottom, I'll have x plus 2. And we can see here we have a function that, hopefully you can tell this has a slant asymptote. But it asks us, when does g of x equal 5? So g of x equals 5. You're going to see now that that line gets plotted, and we're looking to see where the red graph crosses my black graph, which was the rational function. You can see there are 2 places where it crosses, so if you just click the little gray dot where they intersect, those are going to be the x values that you will use. Okay, so we're going to just write those down. Let me go back to my problem. Why does it keep doing this? I don't know why. There we go. Okay, so g of x equals 5 when x equals, and I had negative 4.3589, and when x equals positive 4.3589. Okay, simple as that. All right, last part here, it says determine the end behavior of g as x decreases without bound. When you see that phrase, we're saying x goes to negative infinity. So you'd write this as the limit as x goes to negative infinity of our function named g of x. And then to fill this last part in, we are going to look back at our graph and see where the graph is going on the left side of the graph. So let's go back to our Desmos. So as I can see looking at this graph, the further to the left I go, this graph just keeps on decreasing downward forever and ever and ever with no end in sight. So we would finish that off by saying that the limit is going to negative infinity. Okay? All right, so this should hopefully be a really thorough view of what you'll use Desmos for, and the questions that are on this practice are the kinds of questions you will need to be able to answer on the actual FRQ. Okay?